Hi, so for this session we'll be completing some practice test questions, and the questions we'll be doing are the ones involving having to draw parabolas from a given equation. So for our first question, I think this is question number 15 on your practice test. So for this one, they're asking us to draw this parabola. Now, with this given equation, before we even start drawing, let's have a look and see and analyze what equation we have. Now, we can see that this is not a trinomial, and it's actually in turning point form. So you should be able to identify, hey, this is in turning point form. So the turning point should be, I could see it. So that's why A asks you, what is the turning point? Just by looking at it. The turning point is, this is our x value, but the opposite. So it'd be x will equal positive 2. This is our y value. So the turning point, just by looking at our equation here, x is positive 2, y is positive 1. Done. So that was a skill you should have known. And to identify the turning point, remember, you have to see a squared somewhere and no x on its own. So that's in turning point form. Next, B asks us, is a turning point a maximum, a minimum, or a minimum turning point? To know this is there a negative outside the bracket taken out as a factor? Yes, there is. This negative here indicates that it is going to be a maximum turning point. Okay, so that negative out there tells us it's going to be a maximum, so a hill with a maximum or highest point. If there was no negative, it will be a minimum turning point. C asks us, is it wider, narrow, or the same? So is a parabola going to be wider? How do we know if the dilation will be affected? Is there a number outside of these brackets as a factor? There is an invisible 1, and it hasn't changed. So that means it's going to be the same. So it's not wider, it's not narrow, or the options were wider, narrow, or the same, so it's the same. If I put for example, a 5 out here, my parabola would become more narrow. If I put something less than 1, just say 0.5, it will become wider. That negative doesn't affect dilation, it's the number. Negative out here just says it's going to be upside down, a maximum turning point. Now, to find the y-intercept, it's when x is equal to 0. Now, for this kind of equation, it's not a trinomial, so there is a bit of working out. So when x equals 0, okay, in our brackets, so y equals, the minus is still out there, so instead of x, we put in 0, and then minus 2 squared plus 1. So we've got y equals, what's 0 minus 2? 0 minus 2 is minus 2. Okay, so in here we end up with minus 2. And minus 2 squared is a positive 4 plus 1 is on the outside. So please make sure, because that minus 2 was in brackets and it's being squared, we are saying minus 2 times minus 2. And there's a positive 4 in the brackets, but we still have that negative out here. And those brackets don't have to be there anymore. So I'll just finish it over here. So what we have now is y equals minus 4 plus 1. And minus 4 plus 1 is just minus 3. So the y-intercept is when y is minus 3. The next part of our question, we have to find the x-intercepts. And it tells us to use the difference of perfect squares, or DOPs. There's also in brackets a hint telling us, don't forget to divide this negative. Now, before we do this question, we know this is in turning point form. And if I had a different equation like this, y equals, let's say, x plus 2 squared minus 5. Now, this is in turning point form, so the turning point we can see is when x is opposite, so x is negative 2 and y is negative 5. Okay, that's quite obvious. We can also see there's no negative out here, so it has a minimum turning point. It's not upside down. Now, if we just draw this on a quick graph, so we've got y and x, let's locate this turning point. X is negative 2, just say it's here. Y is negative 5, just there. And our turning point would be just over there. It's got a minimum turning point, so it's going up the hill, and up we go. And as a quick sketch, that's what our parabola will look like. Now, are there x-intercepts? Yes, there are. There are 2 x-intercepts. And we can see, if we had to factorize this here, we can see the difference of perfect squares. Remember, a squared minus b squared equals, in one bracket, a plus b, and the other bracket, a minus b. This is your a here, and that's your b. And because of that negative, we can actually find x-intercepts. And we got it in this form, a squared minus b squared. But what if I now change this whole equation and change one thing? Instead of a minus here, I put a plus. Now, let's quickly draw this. So we've changed the equation. So we have now a different turning point and a totally different parabola. It's got the same dilation. Now, let's just first of all quickly sketch this. So we've got y and x. Now, once again, the x, so the turning point, the x value of our turning point, x is -2, but now y is +5, okay? And we still have a minimum turning point. There is no negative. All I've changed was the y value of our turning point. Instead of a minus here, we've now got a plus. So if 5's up here, +5 for y, and -2 is down there. So the turning point, y is 5, x is -2, there it is. It has a minimum turning point, so it's going like that. And if I drew it, I'll change the color so we can just see it more clearly. If I drew it, there it goes. Now, looking at that, does this have any x-intercepts? No, it doesn't. So that means this equation here, it cannot be factorized. And we can see that. That's because there's a plus here. It is not a squared minus b squared. We are stuck with a plus. And there's no negative over here either. So that's why sometimes we can't actually factorize a parabola, an equation, because the parabola has actually no x-intercepts. Now there's one more thing. I want to do. Using the same equation, I am now, for our third equation, let's just change one thing. So I'm going to now change, the plus is still there. I am now going to add a negative just here. Okay, now this is starting to look like the equation we have up here. Okay, we've got a negative out here, a negative out here, a plus there, and a plus there. Now, let's quickly sketch this. And we know this negative now, instead of a minimum turning point, we now have a maximum turning point. So as a quick sketch, we've got y and x. So our turning point, the x value is -2, the y value is a +5 still. So the same turning point, x is 2, -2, y is 5. There's my turning point. But what has changed? The parabola is now a maximum. It's upside down. So it's going down like that. And because of that negative out there, what do you notice? We now have two x-intercepts. Without this negative here and a plus here, our parabola would look like this. And that would have no x-intercepts. So because we have a plus here, but a negative over here, that means we have x-intercepts. So that means we can factorize this somehow, even though there's a plus here, because of that negative. No negative and just a plus, we have this one here, and it cannot be factorized. So back to our actual question now. So hopefully that has made a bit of sense. And now to approach this, to find the x-intercepts, yes, we have to make y equal 0. So we know this parabola here, it will have x-intercepts, okay? Because yes, we've got a plus here, but there's a negative out here. So our parabola will have a maximum turning point. So there will be some x-intercepts. So to find the x-intercepts, we'll make y equal 0. And we've got x minus 2 squared and then plus 1. Okay? And now this is the tricky part. We are going to somehow turn this into a negative. So we can use a squared minus b squared. And to do that, all we have to do is to start solving this, we have to get rid of this negative out here. Okay? It can't just sit there. To get rid of it, we know it's really a -1. We divide by -1 and we can cross it off. But of course, you must divide this side by -1, the 0. But you must also divide the +1 here by -1 also. Because it's separated by a plus, it also gets a turn. And now by doing that, what's happened? We've got 0 equals, so we've got bracket x minus 2 squared, a positive, so 0 divided by -1 is just 0, but a +1 divided by a -1 gives us a -1. And there we go. So now, is this in the form of a squared minus b squared? Yes, it is. Because we've got a squared here, that's our a. We've got a minus, and 1, we don't have to write it as a surd because 1, we can just add a squared to a 1. 1 times 1 is 1. So it's already squared for us, and that's our b. So we've got a squared minus b squared. All we have to do now is put it in brackets. So we've got 0 equals. So a squared minus b squared equals a plus b in one bracket and a minus b in the other bracket. So a is x minus 2. So a is x minus 2. So we've got x, whoops. We've got x minus 2, whoops. And b is a 1. So a plus b, so x minus 2 plus 1 in one bracket. And then same thing in here, x minus 2 for our a, and then minus 1. So minus 1. And then, of course, simplify what you have in your brackets. So minus 2 plus 1. I'll continue it up here. Oops. It's not working today. All right, try again. So x minus 2 plus 1, so we've got 0 equals, in one bracket, minus 2 plus 1 is minus 1 in one bracket, and minus 2 minus 1 in the other bracket, we'll have x minus 3. And now we solve this to find our x-intercepts. So finally, the x-intercepts, one of them will be positive 1, one of them will be a positive 3. And we have found our x-intercepts. And now we have all the information we need to draw this graph. We have the turning point. That was easy because it's in turning point form. We found our y-intercept, and now we have found our x-intercepts. And we found the x-intercepts by factorizing our equation using the difference of perfect squares. Okay, so to draw the graph, ignore this line on this graph, sorry. Just pretend it's not there. We've got all our points that we have found. Let's first locate these points. So y-intercept is when y is negative 3. So we'll be passing through that point. Change the color. Passing through that point. That's taken care of. Turning point is when x is 2 and y is a positive 1. So x is 2, y is positive 1. Happens to be on the line. Next one, our x-intercepts. So x is 1. And x is 3. They are our two x-intercepts. We know our parabola will have a maximum turning point because of that negative, and we can see that it's going to happen. And now all we have to do is join these points up as best as we can and pass through all these points, curve, and go down, and there is our parabola. So once again, please ignore that straight line. It's just the graph I could find quickly. And there is our parabola. Okay, so it passes through all those points, and what you should also do is the turning point, write it above the actual turning point. So turning point is when x is 2, y is 1, so we can see that clearly. And every other point, so we can see that they're located. So whenever you draw a graph, please make sure the points are labelled. You can write points next to it like this. For example, the y-intercept is when x is 0 and y is negative 3. And the same for the x-intercepts. It does get a bit messy, but it's showing that you understand what you have found. And of course, let's write the equation next to our parabola as well. It's important that we do that as well. Oops, squared plus 1. Okay, thank you.